It's September 7, 2020. I'm Todd Tunn, and today I'm going to be talking about a project I was involved in a few years ago to build a 26-foot sailboat. The video today in particular is going to deal with building the hull. Now, this, as I said, was a few years ago before I had a camera that could shoot video. So what you're going to see is photographs of the process with my narration. Now, I took all these photographs, so I'm not in any of them. But anyway, let's go through the process of building a fiberglass sailboat hull. I'm going to start by telling you a little bit about the boat we were building. This is a half model of the boat that shows you the details. As you can see, it is a 26-foot sailboat with a small cabin house. It has a fin keel, a spade rudder, and in this case, a sail drive. And the sail drive will have implications in constructing the hull, as you'll see. And this hull also has an interned flange that the deck is attached to. And so that's the hull. And what I'm going to talk about is how we built the actual hull and also how we installed the keel. The first thing you have to do when you're building any fiberglass hull is have a mold. This is the mold we use to build this particular boat hull. The four parts of the mold are the main body of the mold, and then on either side of the top of the mold is the flange piece that bolts to the main body, and there's also a similar flange piece at the aft end where the transom is. Now those have to be removable because if they were fixed and you molded up everything inside there, you would not be able to get the hull out of the mold. So the first step before we did anything was to thoroughly clean the mold. So we washed it down and dried it off with clean towels. Then we installed the flanges, and because there's a small seam there, we filled that seam with plasticine or modeling clay and tooled it smooth. And then the next step came, and that is waxing the mold. Because obviously if you don't wax the mold and it's been thoroughly cleaned and has no wax in it, the fiberglass you put in is probably going to stick to it and you're not going to be able to get the part out. So we applied 8 coats of mold release wax to this hull. And I should point out that whenever we were working on the mold, we wore gloves. We never touched the mold surface or the laid up fiberglass surface with bare hands. So 8 coats of wax rubbed on and buffed off, and that's what's happening right here. Once the mold was waxed, the next step is to spray gel coat into the mold. Now we gel coated this hull even though it was going to be painted because the gel coat provides a nice smooth surface against the mold to give a nice smooth surface to the hull. In this case, we're using a vinyl ester gel coat because vinyl ester is less permeable to water than regular polyester gel coat. It's also a little bit more expensive, and I should say it really stinks. So as you'll see as we continue here, most of the time when we're working on this hull, we're all wearing organic vapor cartridge respirators. And so here's the gel coat being sprayed into 1/2 of the mold. And then this mold is on a pivot, so we rotate the mold and spray in gel coat on the other half. After the gel coat cured, we started laying up the actual fiberglass in the hull. Right here you can see the first half of the first layer of fiberglass is put in. And this is 3-ounce chop strand mat set up in vinyl ester resin. Again, the vinyl ester is used to give a more water impermeable layer for the first layer of the hull. The mat overlaps each piece slightly and it also overlaps the center line by a little bit. When we finished putting in this mat here, we rotated the mold 180 degrees and laid up the other half. Here's the mold with the first layer of fiberglass finished. Now this fiberglass does extend underneath the flanges on either side and at the transom, so that the flange in the hull is integral to the rest of the hull. And again, this is 3-ounce chop strand mat, and it's put in largely because it gives a nice smooth finish, and it also will tend to prevent print through of the woven fabrics that we're going to be using after this. Chop strand mat by itself does not provide significant structural strength because it's only made up of about 1.5 inch long strands of fiberglass that are kind of randomly oriented. Also, as we put this in, we applied the resin with paint rollers, and we used a 3/8 inch nap paint roller, and we made up resin in gallon batches and just dipped the paint roller in the resin and rolled the resin on. Once the resin was on, we went over each individual piece of fiberglass with an air roller or fin roller to remove any air bubbles that had been trapped in the. Once we finished installing the first layer of chop strand mat, which took pretty much the rest of the day, we left the hull overnight for that to cure. Now we're using a laminating resin here, which doesn't cure completely. It remains tacky after it reaches its cure, and that is so that we will get good bonds between different layers of fiberglass. At this point, we're ready to start putting in the structural fiberglass that goes into the hull, and we're using a product called 1708, which is a fiberglass fabric made up of 2 layers of unidirectional fiberglass strands that are stitched together with a thin layer of mat on one side, and they are put together in such a way that the fiberglass strands that we were using are oriented at 45 degrees to one another in the 2 layers. Now we've already installed the first layer of 1708 in the upper part of the mold here, and what we're doing is just vacuuming any dust or any other debris off of the first layer of chop strand mat. Now, like with the chop strand mat, we laid out the fabric, which was pre-cut, and then applied resin with a paint roller and air rolled each piece to get any air bubbles out. You'll also notice that everybody in the picture is wearing a respirator. Those all have organic vapor cartridges in it because it's not safe to breathe polyester or vinyl ester resin fumes. After we finished putting in the layer of 1708, we moved on to the next step, which was installing core material. Now this is a lightweight boat, so it doesn't have a very thick fiberglass skin on the outside. It gets its stiffness from having a cored hull. And you can see core material on the upper part of the hull here, and that is 1/2 inch divinyl closed cell foam. It has been vacuum bagged into the hull in polyester resin. Now you'll notice there are some gaps where there's no foam core, near the center line and up on the side of the hull in one spot. The gaps along the center line are where the keel grid will be installed and where the engine mount will be installed, because we don't want foam under those areas because they have to be very structural. And on the side is the spot where we're going to put in a knee to attach chain plates for the rig to. And you'll also notice a darker strip right down the center of the hull, and that is an additional layer of 1708 fabric that we put in to strengthen the center line of the hull. This picture shows vacuum bagging the core material into the hull. Basically what we did is we coated the core and the hull with resin and stuck the individual pieces of foam core into the hull. Then we put a piece of 10 mil polyethylene sheet over the top of that with some polyethylene rope inside, zigzagged up and down to provide a line for air to travel along. And there are vacuum cups at various places in the polyethylene sheet. The polyethylene sheet is sealed to the hull with butyl tape. And once that was in there, we turned the vacuum pump on and pumped it out. And then air pressure would push the core firmly into the resin and draw up resin in any gaps between individual pieces of core. And we left it until the resin kicked. We did the boat in 2 halves this way and produced a nice vacuum bagged bonded surface of core to the outer fiberglass skin of the hull. Now here's the hull after we finished putting in the core material. In this picture we've gone over and lightly sanded the surface of the core to make it smooth and get rid of any resin that had come up through gaps between individual pieces of core. And you can see we're starting to dry fit pieces of 1708 fabric for the next layer of fiberglass, the inner skin of the hull. And you may notice that the area where there is no core looks a little different, and that is because we have laid up at this point an additional layer of 1708 fabric in this area to strengthen it, since it's just going to be solid fiberglass, no core. Here's the hull with the layer of 1708 fabric glassed in over the top of the core, and I'll point out that that 1708 fabric extends just past the center line along the full length of the boat, which is at this point giving us 3 layers of 1708 in the area where there is no core. Here we've finished applying the layer of 1708 fabric over the core for the whole boat, and we're just checking over it, looking for any air bubbles, and the guys are just rolling out any spots that they find where it looks like there might be an air bubble. This is particularly necessary at the zones where we move from core to no core, because there is a difference in thickness of the hull there, so it's necessary to be very meticulous about getting any air out of that transition. Once we finish putting in the layer of 1708 over the core, we let the resin kick off, and then we put in a final layer of 3-ounce trop strand mat so that we would have the same skin thickness on either side of the core to give a nice uniform strength to the hull. And also the chop strand mat gives a somewhat smoother finish to the inside of the hull. After we finished laying up all the fiberglass, which took about 5 days altogether, we let the hull cure for a couple of days, and then we popped it out of the mold, which is a lot simpler than the actual process. Getting the hull out of the mold involved removing the flange pieces for the mold, and then getting the hull to actually release from the mold, and that was done by a combination of hammering soft wooden wedges in between the upper edge of the mold and the hull, and then pouring water into the gap. And our mold also had a fitting on the bottom of it where we could attach an air compressor, so we pumped air into the bottom. And after a lot of banging and pouring water in
and running the air compressor, the mold suddenly released and the hull popped out, and we were able then to use our crane to lift the hull out of the mold and set it on the cradle that you see it sitting on here. So here we have a full fiberglass hull. It is a monocoque piece, one piece, all laid up as a single piece of fiberglass. So at this point, we're ready to start the next step, which is installing the keel. It's worth noting that from the time we actually started prepping the mold until we had the hull out of the mold took approximately a week, including the curing time for the hull before we popped it out. And the actual total construction time for this boat was just over a year, because it's a semi-custom boat, and except for the hull, everything in the boat was custom. So this just illustrates one aspect of fiberglass boat building, and that is the actual fiberglass fabrication of the hull is a very small part of the actual build. The next step was to install the keel. There are two parts to installing the keel. The first part was to build a fiberglass grid that the keel is attached to and install that grid. The keel grid consists of several layers of 1708 with a series of, if you will, sort of ribs attached to it. It's laid up as a single part on a mold, and it is the mold is designed to match the curvature of the hull. And it was, of course, it didn't quite match, so it involved test fitting, grinding, test fitting, grinding until it actually fit. And here you can see one of the guys working on the final fitting of the keel grid, and you can see that center line piece of string there, and that is used to get the keel grid in the right place by hanging a plumb bob from above so that it just touches that line and then extends down to the keel grid to give us a location for the center line. And once we have everything fit, the keel grid is fiberglassed into the hull. And this is going into the area where we left the core out so that we have solid fiberglass here. Nothing soft like foam core that could be compressed by the keel loads. And each of those ribs you can see there will have keel bolts going through it. Once we had the keel grid bonded into the hull, we started prepping the outside of the hull to install the keel. The keel is a lead casting. It's a bulb keel on a fin. The whole thing is lead with stainless steel keel bolts sticking up out of the top of it that were installed when the lead was cast. We made a wooden pattern of the keel and sent it off to the lead foundry where they did the casting. And this lead has had 3% antimony added to it to make the lead a little bit harder than pure lead would be. Now, the first step was to prep the hull itself for installing the keel. Now, this had to be done because the top of the keel is flat, but the bottom of the hull is curved. So what we did was made a wooden pattern of the top of the keel, which you can see there just above the keel. It's white, and it's covered with plastic. And what we did was we laid up fiberglass in epoxy resin on top of that, and before it cured, we ground off the gel coat where that would go, and then after a lot of careful alignment to make sure it was in the right place so the keel bolts would come out into the ribs of the keel grid, we bonded that little bit of fiberglass to the bottom of the hull to make a flat surface that the keel could mate to. Once the fiberglass mating surface on the hull was cured, we drilled holes for the keel bolts using a template that we had made to show their positions. And then we dry fit the keel, which is what we're doing right here. Now this keel weighs 1,600 pounds, so we have it on a little hydraulic lift, which we could roll under the boat, and believe me, it took a little effort to roll that thing under the boat, and then jack it up the 7 or 8 inches or so it took to get the keel bolts in through the holes and get the top of the keel flush with the bottom of the boat. And we dry fit it just to make sure that we had a good fit, and we had to do this a couple of times with a little bit of grinding between dry fits to get a good mating surface between the top of the keel and the bottom of the hull. Once we were satisfied with the dry fit of the keel, we were ready to do the actual install. That involved jacking the keel up until the bolts were in the holes, and then applying a liberal coating of 3M 5200 permanent adhesive to the top of the keel. Once we had the 5200 on top of the keel, we jacked the keel up the rest of the way until we were actually starting to lift the hull up. Once the keel was in place, we cleaned up the bulk of the 5200 squeeze out and went into the boat and tightened up the keel bolts. At this point, we left the keel jack in place for about a week because 3M 5200 takes about that long to cure. And then after that week, we were ready to take the jack off and see if the keel would stay in place. Here's the keel hanging, supported only by the keel bolts. And when we backed the jack off, we gave the hull to keel joint a very close inspection to make sure that there was no separation. And there wasn't, so we were very happy with the keel install, and that part of the boat construction was finished. Okay, that's the end of this video. Hope you enjoyed seeing a little bit about how a fiberglass boat hull is built and how we went about installing a 1,600-pound lead keel onto the fiberglass hull. So, I'd appreciate it if you'd subscribe to my channel if you haven't, and don't forget to click the notification bell. And if you liked the video, give me a thumbs up. Thanks for watching.